Today we're going to start 5.3, identifying proportional relationships. So that first word that you saw there, we're going to go ahead and write down this definition, what a proportion is. All right, as you can see, a proportion is two ratios that are set equal to each other. So as you can see, 1 is to 2, or 1/2, equals 3/6, okay? Now, I'm going to teach you a method called cross products. I think this should come as a review to you. But with cross products, basically what you're doing is you are going to be multiplying the number that is diagonal from the original number. So 3 times 10, you're going to go ahead and rewrite it as 3 times 10. And then we'll multiply the other two that are diagonal from each other. 4 times x. Once again, remember it says they are two ratios that are set equal to each other. So it is important that you have that equal sign in between them. Number 1 asks us to tell whether or not the ratios form a proportion. If they equal each other, then that means they form a proportion. So this says 6 to 4 and 8 to 12. So we're going to go ahead and rewrite this right here as 6 over 4. Equals, because remember a proportion needs to have an equal sign in between them, guess what this is going to be written as?
8 over 12.
8 over 12. Now what we're going to do is we're going to go ahead and use those cross products that we just talked about. What's across from the number 6?
12.
A 12. So I want you to actually circle it with your pencil. What's across from the 4? 8. Now beforehand we've talked about dropping down our equal sign so that our work stays nice and neat. I want everyone, before we do anything else, go ahead and drop down that equal sign. The first thing we're going to do is we're going to start with this top number up here, and that is telling us to multiply 6 times 12. Equals, guess what the other side is going to equal? 4 times 8, or 8 times 4. Order does not matter. Okay, now we're going to go ahead and drop down the equal sign. Let's work right here from this first one. Guys, what's 6 times 12? 72. And then on the right-hand side, what is 4 times 8? 32. Class, does 72 equal 32? No. So the correct answer is no, they do not form a proportion. And here's what I want to actually see you do is just take your pencil and put a little slash mark through that equal sign, because this says 72 does not equal 32. All right, and that is how you tell whether or not something forms a proportion. Problem B, 10 to 40 and 2.5 to 10. How do I do the first one as a fraction, class?
10 over 40.
10 over 40. And then remember, we're writing a proportion, so we want to put our equal sign. And what is the other fraction going to look like? 2.5 over 10. Does anybody want to do this for me? Nehemiah, go ahead.
You drop down your equal sign.
Okay, we're going to put the equal sign down.
And then on the left side, you're going to put 10 times 10.
Okay, show me this with your circles. Okay, I want to see what you're multiplying by. He says on the left side, we're going to go ahead and do 10 times 10.
And then the right side, you're going to do 2.5 times 10. Times 40.
Okay.
And then drop down your equal sign. And then 10 times 10 is 100.
Very good. 10 times 10 is 100. And what about 40 times 2.5?
40.
He's going to do the
2.5 equals 100.
All right, do those equal each other?
Yes.
Yes, so your correct answer, you're simply going to write yes, they do form a proportion. All right, the next one might be slightly trickier. Why is it trickier, class? It's fractions. Do we know how to divide fractions?
Yes.
We do, so we do not have to be scared of this, okay? So the first part, we're going to do 1/2 over what, guys?
1/4.
Over 1/4. Okay, remember all we're doing is you just take the first number and you divide it by the second number. I'm going to set them equal to each other because it's a proportion. 8 to 4, how do I write that as my fraction? 8 over 4. Okay, so now once again I want you to go ahead and circle what your cross products are. And we're going to drop down our equal sign. On the left-hand side, what should I multiply together, Brody?
On the what side?
On the left side.
1/2 times 4.
Okay, very good. 1/2 times 4. And we could put 4 over 1 since we're doing fractions. Brody, what do I do on the right side?
8 over 1 times 1/4.
Okay. Once again, it doesn't matter whether the 1/4 comes first and you multiply that times 8 over 1, or if you do the 8 over 1 times 1/4. You're going to get the same answer no matter what. All right, on the left side, Brody, is there anything I can cross reduce?
Yes.
What should I do?
2 and 4.
Okay, what do they become?
2, a 1, and 4, a 2.
Very good. Is there anything on the right side I can cross reduce?
Yes. The 8 and 4.
What do they become?
8 is 2 and 4 is 1.
All right, very good. Now looking at the left-hand side, what do you get for that answer?
1 half. 2 over 1 and 1.
2 over 1, which is 2. And what do you get on this right-hand side?
2 over 1 is 32.
All right, so is the answer yes or no?
Yes.
The answer is yes. Those are proportional because they equal each other using cross products. All right, next one, problem D. I want you guys to go ahead and try it out with your partner, and we'll talk about it here in just a minute. All right, who feels comfortable doing problem D for me? Nikki, what should I do?
6 over 9 equals 12 over 18.
Excellent.
You're going to circle 6 and 18, and then 12 and 9.
Very good.
6 times 18, bring down the equal sign. 6 times 18 is on the left. 9 times 12 is on the right.
Very good.
108 and equals 108. So your answer is yes.
That is correct. How many of you guys got the same thing that Nikki and her partner got? Excellent. All right, try the last one on your own. Who wants to do problem E for me? Javaria, help me out. What do I do?
Okay, so you want to make those little 2 circles by the one. Oh, no. Bring 2/3.
2/3
to 4 over 5.
equals 4/5.
Yes. And then you want to circle the multiplication.
Okay.
And then you want to write down 2 times 5 equals 4 times 3.
All right. What is 2 times 5?
10.
What's 4 times 3?
12.
Do they equal each other?
No.
No. So class, do these form a proportion?
No.
No. Remember, slash that little line through it. 10 does not equal 12, and the answer is no.
We always have to slash a line.
All right, the next one asks, tell whether this table here, if the x and the y are proportional. The way that we are going to decide that is by finding the value of the ratio. So there are 4 different steps here. I'm going to have us just go ahead and label. That's the first box. This is the second box, the third, and the fourth. Go ahead and label that for me, please. And we're going to look at the first box. Now remember, if I am going from top to bottom, what sign do I do? We divide. So what am I dividing here on the first box?
X and Y.
X and Y, what numbers?
1 half and 3.
1/2 divided by 3, which means 3 over 1. What do I do next, Madison? Nope, this is totally different. This is dividing fractions. Am I allowed to divide fractions? No. So what method do I need to use? KFC. Okay, this is going back to our lesson from yesterday. And what's the answer?
1 over 6.
1/6. Okay, that's the value of our ratio. I want you to go ahead and box that in. We are going to see if the value of the ratio is proportional or is equal to every single other one that's there in our graph. Okay, so let's go ahead now. We're going to focus on this second section right here. Okay, so let's write a little 2 over here because we're looking at the second section. I'm going to divide the top one by the bottom one. So what should I write first, class? 1 over 6. Do I need to do anything to that?
No.
No, that was a real simple one. Box it in. The value of the ratio for that second block is 1 over 6, and that's as simplified as it gets. I'm going to go ahead and come over here to the right-hand side for number 3. I take the top number and divide the bottom number. Sierra, what should I write? Okay, we're just going to go like this. 3/2 divided by what number? 9 over 1. Okay, Sierra, keep going. What do I do?
Oh, I thought that was my phone.
Okay, we're going to KFC it. What do I do? Keep the first. Okay, can I cross reduce anything? All right, what do I do? What do they become? All right, and what's our answer? 1/6. Guys, so far, does it seem like these are equivalent? All right, I've got the final one. Alexis, what should I write? Okay, do 2 over 12. Can that be reduced at all, Alexis? What's it become? 1/6. Class, does it appear as if those are all proportional? Yes, because each of them had the same value of the ratio, they are proportional. So the correct answer is yes. Okay, problem B, I want you guys to do it with your partner to try to figure out if these are proportional or not. All right, let's see what you got. As you can see, the first one, the fraction would be 2 over 4, which reduces to what? 1/2. Okay, I'm going to box that in. That's the value of my ratio there. Number 2, what do I put?
4 over 2.
4 over 2, which would be?
2 over 1.
2 over 1, which is? 2. Okay, are they proportional? No. So listen, at this point, you technically could just stop because you could already tell they are not proportional. But let's say you kept going. Number 3, what would you have put?
6 over 1.
Which equals?
6.
Which equals 6. 6 divided by 1 is a 6, okay? The last one, what do I have to do?
8 over 1 times 2 over 1.
8 over 1/2. So you got to divide those, use the KFC method, and then your value of your ratio for the fourth one is?
16.
16. Class?
No.
Are all of those proportional? No. Remember, if something's proportional, it's equal to each other, and those are not equal to each other because the value of their ratio was different on all 4 of them. For the next problem, it says you swim 20 laps in 16 minutes. Of the total laps swam, you completed your first 4 laps in 2.4 minutes. Are the rates proportional? Okay, so we got to see how we can figure this out by writing them in fraction form. The first thing it says, we take 20 laps. How long does that take me, class?
16 minutes.
It takes me 16 minutes. So we're just making it into a fraction, 20 laps for every 16 minutes. If it's a proportion, what do I need to do in between my 2 fractions? Put an equal sign. So let's go ahead and put our equal sign. What is the other ratio that I'm comparing it to, class? 4 laps in 2.4 minutes. So let's go ahead and use our cross products to find this answer. What should I circle with the 20 laps?
2.4.
Okay, 20 laps and 2.4. What else should I circle?
4 laps.
16 minutes and 4 laps. Drop down that equal sign. What should I multiply on the left side? 20 times 2.4. What do I multiply on the right side, guys?
4 times 16.
Okay, 4 times 16, 16 times 4, either one's fine. Taylor, what is 20 times 2.4?
20 times 2.4.
48 is correct. Charbel, on the right-hand side, what's 4 times 16?
4 times 16 is 64.
64 is correct. Ayana, does 48 equal 64? No. So the answer is no, that they are not proportional to each other. All right, which really does make sense. Typically, your first 4 laps, you're probably going pretty fast. And then what happens as you swim up to 20 laps? You get tired, you get worn out. So it makes sense that those probably would not be proportional. All right, for the next problem, you do 120 sit-ups in 3 minutes. Your friend does 148 sit-ups in 3.5 minutes. Do these rates form a proportion? Help me with it, William. What should I write as my first fraction?
We should write 120 over 3.
120 sit-ups over 3 what? All right, then what?
And then we should write equals 148 sit-ups over 3.5 minutes.
Okay, so here's one thing I want you to really notice. When you're forming a proportion, please make sure, see how this says sit-ups on top? Make sure the numerators are the same units, all right? Then you'll see the next part underneath here. These are minutes and those are minutes. They need to be the same units, sit-ups per minute. You cannot switch it on the other side and do minutes per sit-ups, okay? You got to make sure they are equivalent like that, all right? So now, what should I do next, Alexis? Okay, we're going to circle the cross products here. And now what?
120 times 3.5
Very good.
and 148 times 3.
Very good. Drop down your equal sign. Haley, what's 120 times 3.5? 420. Nikki, what's 148 times 3? 444. Class, do these equal each other? No, because they do not equal each other. Our correct answer is no, they are not proportional. All right, so this is tonight's homework from page 200. I'm going to give you a few minutes. You guys can go ahead and get started on the assignment.